Okay, we're going to finish up section 1.3 here. So problem 49 is where we're at. It says, how many triangles of any size are in the picture of the cat below? Okay, and I've got this split up into three groups here. The tail of the cat, the body of the cat, and the head of the cat. If you just look at the tail of the cat, here's 1, and then 2, and then 3. Okay, and then 4, and then 5, and then 6, this big one here, and then 7 is how much I count in the tail of the cat. And the body of the cat has got the body and the 2 feet there that I'm counting. And then the head of the cat, I got the head, and then the mouth, 2, 3, 4, 5, 6, 7, 8. And if you combine the eyes, 9 and 10. Okay, and then adding these together gives me 20. So 20 triangles is what I count there in problem 49. Problem 50, how many triangles of any size are in the figure below? Okay, so the first thing to notice here is that because I've got a pentagon, I should have something that'd be a multiple of 5. Okay, since any triangle that I count that's the side of the pentagon is also going to be 5 of them. Okay, if I count the individual triangles here, so here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've got the kind of a picture here shaded, 10 of those. And now all the other triangles that I'm going to have to count are going to be where I'm combining triangles, so or combining shapes, I should say. So here's 1 and 2. Okay, and I've got those shown there. Now, those 2 triangles are only using one side of the pentagon. Okay, and there's 5 sides of the pentagon. 2 times 5 gives me 10. Okay, so there's 10 of these kinds of triangles that I'm seeing there. Another kind of triangle is this one. Okay, where you got a couple of shapes in the triangle, in the pentagon there that you're forming a triangle, and this is using one side of the pentagon. Again, there's 5 sides of the pentagon, so there's going to be 5 of these kinds of triangles. Okay. Here's another one that if you combine these 3 shapes, you form a triangle. And now I'm using one corner of the pentagon. There's 5 corners of the pentagon. Okay, so there's going to be 5 of these kinds of triangles that you'd have to count. And then now inside the smaller pentagon, if you create this shape here, for example, that would be a triangle, and you're only using one corner of the small pentagon. Again, there's 5 corners of the small pentagon there, so there'd be 5 of those kinds of triangles that you could make. Okay, when you add these together, 35 triangles total is what you get. Okay. Problem 51 says that if A, B, and C are digits for which 7a2 minus 4,8b equals c7,3, then a plus b plus c is what? So in problem 51, we're going to use an exercise. This is basically an exercise in borrowing, and I've got an example here, 572 minus 398. In this problem, you'd have to borrow. Okay, so 2 is smaller than 8, you have to borrow 1 from the 7 to make that a 12. 12 minus 8 gives me 4. I borrowed 1 from the 7, so that's a 6. 6 is smaller than the 9, so I'm going to have to borrow 1 from the 5 to turn that into a 16. 16 minus 9 gives me 7. I borrowed 1 from the 5 there to make that a 4. 4 minus 3 is 1, so 174 would be the answer. Okay. This one's going to be kind of similar to what I see there. So 2 is smaller than 3. I'm going to have to borrow 1 from column 2 to turn that into a 12. Okay, 12 minus 9 gives me 3, so B is 9. I borrowed 1 from the second column there, and that would turn it into a 5. Okay, 5 is smaller than 8, so I'm going to have to borrow 1 from the 7 to make that a 15. 15 minus 8 gives me 7. Okay, A was 6. Okay, so you had to borrow 1 from 6 to turn that into a 5, and then you had to borrow 1 from the 7 to turn that into a 15. So A was 6. 6 minus 4 gives me 2. Again, I'm borrowing. Okay, so C would be 2. Okay. Problem 52. You have 8 coins, 7 are genuine, and 1 is a fake, which weighs a little less than the other 7. You have a balance scale, which you can only use 3 times. Tell how to locate the bad coin in only 3 weighings, and then show how to detect the bad coin in only 2 weighings. Okay, so 3 weighings isn't bad at all. You're just going to continuously split in half. You got 7 coins that all weigh the same amount there, and 1 is a fake, which weighs a little less. So if you use a balance scale, one side is going to weigh a little less than the other. Okay, so if you go 4 and 4, one side is going to weigh smaller. So whatever the smaller side is, the 4 coins, you're going to split that in half and go 2 coins and 2 coins. Okay, again, one of these groups contains the fake coin there. So whatever that group is, that's weighing on the balance scale, slightly different there. You're going to select those 2 coins and go 1 and 1, and so you'll be able to locate the bad coin in 3 weighings with no problem at all. Okay, now how about in only 2 weighings? 2 weighings is a bit difficult, although the trick here is to get to 3 groups. Okay, you're going to get 1 group of 3, 1 group of 3, and then 1 group of 2. Okay, and disregard the 2 coins, so you got 3 and 3. Okay, I'm going to call this case 1 and case 2. So case 1 is if the 2 sides are equal. Well, the 2 coins that you eliminated there, one of them is going to be a fake there. So if you put 1 on one side, 1 on the other side, and suppose that the other side is the side that makes it not balanced there, then you identified the fake coin. Okay, case 2 is if you put 3 on one side and then 3 on the other side and they don't balance. Okay, what happens if they don't balance? Well, choose any 2 coins from the side that doesn't balance there. Okay, so you got 3 coins left, and you're going to choose any 2. Okay, case 2A, if you put 1 on one side, 1 on the other side, and they balance, well, then the one that you did not select was the fake coin. Okay, so you identified the fake coin in only 2 weighings. Case 2B, if you put 1 coin on one side and the other coin on the other side, and they don't balance, well, you still identified the fake coin there. Okay? So problem 53 says when 10 to the 50th minus 50 is expressed as a single whole number, what is the sum of the digits? Okay, so what some people might do is they might just say, oh, well, that's just to go to the calculator and type it in, right? Well, so 10 to the 50th gives me something in scientific notation, so that's not going to work. Okay. It'd be way too easy if you could just go to the calculator and punch it in, right? So the hint there, you're going to use inductive reasoning. Okay, so remember inductive reasoning is what the first 2 sections are all about. You're trying to establish a pattern. Okay, and the pattern that I want to see here is using smaller exponents for 10. Okay, because these are things that I can do. Okay, so 10 squared is 100, minus 50 gives me 50. 10 cubed is 1,000, minus 50 gives me 950. 10 to the 4th would be 10,000, minus 50 is 9,950. 10 to the 5th is 100,000. Minus 50 gives me 99,950. 10 to the 6th would be a million, 1 and 6 zeros. Minus 50 gives me 999,950. Okay, so it looks like from the pattern here, whatever the exponent is, you're going to have two less 9s. So I've got 4 9s here with an exponent of 6, 3 9s with an exponent of 5, 2 9s with an exponent of 4, 1 with an exponent of 3. Okay, so if I have an exponent of 50, I should have 48 9s. So if I take 48 times 9, I'll get all those 9s when added. Okay, plus 5 plus 0. The plus 0 is not going to do anything, but plus 5. I'm looking at 437 there as the total. Okay. Problem 54 is a kind of a similar one. What is the last digit in 3 to the 300th power? Use inductive reasoning. Okay, so what many people might do here is they might just go to the calculator and punch it in, right? So 3 to the 300th power gives me an overflow of information, which means that 3 to the 300th power is way too big. My calculator can't even handle it, okay? So this isn't, again, it's not just to go to the calculator and punch it in type thing. The hint there is for me to use inductive reasoning. Okay, so let me look at smaller exponents, ones that my calculator can handle, or I can do in my head. So like 3 to the 1st gives me 3. 3 squared is 9. 3 cubed, 3 times 3 times 3 gives me 27. 3 to the 4th, 3 times 3 times 3 times 3 gives me 81. 3 to the 5th gives me 243. 3 to the 6th gives me 729. 3 to the 7th gives me 2,187. And 3 to the 8th gives me 6,561. Okay, and I see this, now all I care about is the last digit. Okay, so 3971, here's 3971. Well, at this point, I'm feeling like maybe there's a pattern going on, okay? So let me keep going. 3 to the 9th gives me 19,683. 3 to the 10th gives me 59,049. 3 to the 11th gives me 177,147. And 3 to the 12th gives me 531,441. So again, I see this 3791. Okay, so at this point, I feel like there's, a pattern going on, and I'm going to use inductive reasoning to find out what 3 to the 300th is. Okay, I've got 3 to the 12th. Now, if I continue to make columns of 4, and I make 25 columns, the very last number in the last column would be 3 to the 100th power, which would be something that ends in a 1. Okay? Now, what if I make another row here of 4 columns in each row? Okay? 25 columns would give me, the very last number in the last group there would be 3 to the 200th power, which would be something that would end in a 1. Okay? And then if I make 25 more columns, again, what would be the last number in the very last column there would be something that would end in a 1, and that would be whatever 3 to the 300th power is. Okay? So based on what I see here, and using inductive reasoning, 1 would be what I would guess. Okay? Problem 55 is the last problem there. Suppose you had the chance to work for 3 weeks and could choose one of 2 methods of payment. Method 1 is where you could choose to be paid $1 on the first day, $2 on the second day, $4 on the third day, $8 on the fourth day, and so on, with the amount doubling each day. Or method 2 is where you could choose to receive $1 million in one lump sum. Which method of payment would you prefer? And what is the difference in the amounts of these two types of payments? Okay, so what I've done here is I've made a chart. So on day 1, I would have made $1. On day 2, I would have made $2. On day 3, I would have made $4. Day 4, I would have made $8. So the amount is doubling each day. Day 5, I would have made $16. And these are all powers of 2. Okay, so anything that's 0 power gives me 1. 2 to the first is 2. 2 squared gives me 4. 2 to the third gives me 8. 2 to the fourth is 16. 2 to the fifth is 32. Okay, and I'm going to keep going here. So on day 21, I'm only working 3 weeks at this job here. So on day 21, I would have 2 to the 20th power. Okay, so 2 to the 20th power, if you were to enter that in the calculator, it gives you a 1,048,576. So already you can see method 1 is going to be the better method since you'll be making over $1 million. Now, the nice thing about method 1 is that, so this is the only the amount that I'd be making on day 21, plus the amounts that I would make on the previous 20 days. Okay, so method 1 is going to be by far the better method. Over here on this column, I've got the total that I would be making at this job. Okay, so the total from day 1 is where I take 2 to the first minus 1, or 2 minus 1 gives me 1. Okay, the total on day 2 would be 3. So if I take 1 plus 2, I get 3. The total on day 3 is 7. So if I take 1 plus 2 plus 4, I get 7. The total on day 5 is 15. So if I take 1 plus 2 plus 4, that's 7 plus 8 gives me 15. Okay. So what I've got going on here is I've got basically powers of 2 minus 1. So 2 minus 1 gives me 1. 2 squared is 4. Minus 1 gives me 3. 2 to the third is 8. Minus 1 gives me 7. 2 to the fourth is 16. Minus 1 gives me 15. 2 to the fifth minus 1 gives me 31. 2 to the sixth minus 1 gives me 63. Okay, so basically I'm going to take what would be 2 to the 21st minus 1. Okay, and if I type in 2 to the 21st power minus 1, then here's what I get. So $2,097,151. Okay, so you would more than double your money if you chose method 1. So method 1 is going to be by far the better method there. Okay, that'd be a difference of $1,097,151. So if I subtract $1 million there from this amount, that'd be what I'd get. Okay, the homework in this section is this worksheet. So be sure that you know this worksheet. This is section 1.3, and we're done with chapter 1 now. Okay.